Okay, students. So now we have a lecture on the example to understand the neural network model. Why we have this lecture today? This is simple concept because previous lecture we have seen the total introduction part of the neural network. In the neural network, we have discussed what is the neural network and how many layers we have and what is the meaning of the perceptron and why activation function is required. And we know the activation function, that is sigma, so we will use activation function sigma only today only for our calculation purpose only. From this point we have to understand an example in detail में what is the functionality, what is the things which is to be interpreted by our neural network model. So we have a very small network and model, that is a neural network model, from which we will try to understand our functionality of the neural network in detail. So let us start this class with this statement. With approximately 100 billion neuron, or we can say 200 billion neuron, as we have seen yesterday, the human brain processes data at speed as fast as 268 Mbps miles per hour. In essence, the neural network is a collection of the neurons connected by the synapses. Synapses means the interconnections between the neuron. And in our attribution neural network, we have interconnection. This collection is organized into the three main layers, as we know: input layer, hidden layer, and output layer. So you can have the many hidden layers, which is identified by the multiple perceptron, or we can say the multi-layer neural network, and that is applicable into the our deep learning in a deep learning model. So sometimes it is also known as the deep neural network. So in an artificial neural network, there are many or several inputs which are called the features. I am speaking, there are several inputs will be there, not a several input layer. Layer will be only one, but features or inputs will be many. So we can have the one, two, three, or many n number of the input we can have. I'm talking about inputs only. I'm not talking about the input layer. And produce a single output, which is also called as a label. Okay, so this is a simple terms we have to understand. From this point, we have to start our problem and simple this. If this slide is visible to all right now, the R studies and R step input and
Yes, sir.
Yes, sir.
test score. So this is our problem.
Yes, sir.
So that is the our problem we have. So I'm explaining all the things properly. So I hope the picture, the idea will be clear to all in concise. So without wasting much time, I'm writing everything over here, and this is our problem. So we have two features. This is our features. One is R studied, and total are the sleeping. So how many times you will study in a day and how many times you will like to sleep? So that is our features. So this is the our input information, that is known as our features. Step by step I will ask you, and whenever you feel any problem, so you can ask me. And test score, we have the, if you are spending the 2 hours study, sleeping hour, we have the 9 hours, and that is our input, we can say. So our output, we are getting the 92%, we can say, and this is can be written like the 0.92. Why I am writing 0.92? Because it's very clear concept. Because a neural network can ranges from 0 to 1. That's why we can write this 0.92. So this is what this is known as our actual output. Now can we say this is our actual output? Can we say?
Yes, sir.
Yes, sir, we can.
So we have these two features. At these two features, we are getting the our actual output 92% or 0.92. If we have these features, we have the 1.5, 1,5, 86, and we have the 3,6, then we have the 89, and if we have this point, so we have the 4,8. So we have to do calculate. So it is not given, but whatever is the given information we have to do properly. Let me draw the proper example over here for a betterment, and you can easily understand the thing. So what is this problem is saying to us? This problem is saying to us, we have two inputs. These two inputs can be identified by the 2 and 9. and there could be the other hidden layer, okay, and one as outputs. So these inputs are given to us, these inputs are given to us. So we have a 2 comma 9. This will be connected like this one, and this will be connected like this one. This will be connected, and this will be connected. So intermediate parts are not given. Our given part are input and output. So the highlighted points or the under, we can say darkened points are represented by the given inputs or given outputs. So we have the 0.92. So this is given, and this is given. The other parts are not given so far. So from this pattern, we have to solve the problem. We have to apply the calculation to determine really are we getting the 0.92 based on this input. So some other details also will be given. So first we will solving the A part, first part. Okay, so based on this parameter we are passing. Now let me know right now the problem is clear. This is our problem. So what is our problem?
Yes, sir.
What is the problem? By neural network model, determine the given actual output is meeting with predicting output. So if it is not meeting, it means we have some error. So that is the point you have to understand. So now from this point we have to solve our problem and we have to understand the thing properly. So keep in mind, I just suggest to all the students, note down these input values and note down the output values. So note down this value 0.92, that is our actual output, and our features are the 2 comma 9. So we are focusing on this point right now. Now note it down.
Yes, sir. Noted.
Okay, good. Now the calculation behind our network, we have a 3 comma 2 matrix, means 3 weights and 2 inputs. So this is also given. Previously it was not given, so but now the diagram, in the diagram we have given. We have assumed the previous diagram, but this is will be given. So now this is given into that in our data input 2 and 9 our input. So our matrix will be represented by the 3 by 2. It means 3 we have a weight, 3 weights will be there for 2 inputs. So 3 bits are given. It means how many hidden layer will be? That defines that we have the 3 hidden layer, 3 hidden nodes at the hidden layer. So it was not defined the multiple hidden layer will be. So we are assuming that there will be only the one hidden node. And now in the exam time, I will give you the structure of the neural network. From the structure, you have to identify what is the input node and how many hidden layer we have and at what we have to do. So here, but we are assuming the thing properly. So for solving our problem, and output data represented by y is a 3 comma 1. It means 3 weights and 1 output only. So this is clear to right now. Is it clear to right now?
Yes, sir. Clear.
Yes,
So
sir.
we will use this diagram for our calculation purpose. So I suggest to all the students, please keep in right now the paper and pencil. So I will ask the question from everyone. So you have to speak over here. So the image of the breakdown, the information we have that will be breakdown that our neural network actually does to produce an output first products of the random generated bit, that is the this point. This is what actually 0.2, 0.6, 0.1, 0.8 and 0.3 and 0.7 are the weights, random generated weights we have, and that will be connected to the our each and every node. So nodes will be connected by the some weight. So in our tree structure, if you remember, the every tree nodes are connected to each other by having some weight. So unlike from this pattern, we have the our neural network or our artificial neural network. Whatever the network we are designing, it will be represented by the some weights. This weight define the meaning or the sense of the connections. So the corresponding inputs are summed to arrive at the first value of the hidden layer. So these sums are the smaller points. So okay, so this everything I will tell you with the practical, with the part of the our numerical portion. So I'm speaking once again. Weights are given, that is the 0.1, 0.2, 0.6, 0.1, 0.8, and 0.3 and 0.3. So we can say this would be our weight. Okay, I can say over here 0.2, 0.6, 0.1, 0.8, 0.3, and 0.7. So these weights are given. Now it is clear right now. And these weights are given.
Sir,
0.2
can
is
we write that weight, sir? 0 point. Okay, okay.
okay. We can. It is already written.
Okay, sir, no.
No. So now we have the this weight 0.2, 0.6, 0.1, 0.83, and 7 we have. So I can write like this one. So for a betterment, suppose W1 we have a 0.2, W2 we have a 0.6, W3 we have a 0.1, W4 we have 0.8, and W5 we have the 0.3, and W6 we have the 0.7. Okay, so this is your W1 for understanding purpose only. Now after this one we have this, so this will be represented by the W2. Okay, now after this one we have the this node, that is the this node, so that is our W3. Now we have this node, so this will be connected from this part, so this would be your W4. And now 0.3 we have, so this would be your what, this would be your W5, and this would be your W6. Now these weights are already given, so is it clear to all right now?
Yes, sir.
Yes, sir.
So my dear student, just here do the proper calculation. As first calculation I will show how to do so, and next calculation you have to do so. And it is just required to understand the thing properly. So just keep in mind, we have our input. So we have a input, I can write over here for a betterment, for understanding purpose. Input we have a 2,9. We don't have the voice, so no issue about the voice, but if we have, so then we can add, else we can use the weight. So weight we have the 0.2, 0.6, 0.1. So these three weights are connected by our input to, can we see? You can
Yes,
check.
sir. Connected.
Connected. These two
Yes,
weights
sir.
are
Yes.
connected by our two inputs. Okay, good. And other weights are, we have the other weights are 0.8, 0.3, and 0.7. These three weights are connected to the our input number, input value 9. 9. Is it true?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Yeah. Good. Super. So this is the time we have to calculate the, so I'm assuming at hidden layer, this is the node H1. Suppose this is a node H1, and this is the node H2, and this is the node H3. So we have to use the calculation. First I'm doing the calculation for node H1. Okay. So first calculation I am doing, we have this one. So question we have, what is the input value of node H1? So what is the input value of the node H1? So this is our first part, and we have to do. So can anyone tell me right now, or should I tell? Can anyone tell me right now how to calculate the input value of the H1?
So W1 into X1 and W2 into X2.
Definitely, with the help of the summation function we can do. So okay, I can write over here by using the summation function. By using the summation function, yes, of course we can. So we can do the simple calculation like this one. 2 into 0.2, can we write?
Yes, sir.
Yes, sir.
Because this, because H1 node, we can say This is connected by the 0.2 weight only. Okay, 0.2 weight W1 is connected to the only H1 node. Am I right?
Yes, sir.
sir.
Or for simplification, I can say like this one. I can say like this one for a betterment, so everything will be more clear. We can say 2 into W1 plus 9 into W4. Can I say like this one?
Yes.
Yes, sir.
So
Yes,
2
sir.
into 2 into 0 2 plus 9 into W4. What is the value of W4? 0.8.
0.8.
Super. If I'm using so 0.4 plus 9 into 8, so it would be 7 point.
0.72.
7.6.
So finally we have the
7.2.
7.6.
Yes, sir. 7.6.
No, sir.
This
7
would
point. Acha, total.
total. My dear, I'm adding both things. Now this you got this value. How we are getting?
Yes, sir.
Yes, sir.
So I can write this value over here for betterment. So this is the input value. I can write over 7.6, and next value we have to calculate the out value. So this is a big question, out value, how to calculate. And this out value will be the input for the other node as well. So just forget the other node right now. Just think about this node only. Now we have the out value. This is known as the out value. Out value of node H1. So what is the out value of node H1? Can anyone tell me right now how to use this thing? How to
Yes, sir.
use?
Yes.
Yes, please tell me. How to use? Just tell me the only way by which we can calculate.
Sir, 2 into. Sorry,
Hmm?
sir. Can
I'm asking the out value.
X
What would the
for X.
if you don't know, no issue. But if you know, so please speak properly.
So 7.6 into W7.
W7. Why should I multiply by the W7?
So we have to apply some activation function here.
Yeah, that is a great point, because if you remember the my words, as I told you yesterday, we have an input, we have a weight and biases, and then we have the summation function, then we have the activation function, transfer function, and this transfer function will determine the activate the our neurons. So we got the input value. So after input value is required to calculate to charge the our node. And after this charge, so now this what would be the output of this node, and that is used by the activation function. So here we will use this thing with the help of the activation function. Now clear right now?
Yes, sir.
So what is the our function we will use as initial level logistic regression? We have seen sigmoid function. Sigmoid function. Just use a sigmoid function. And what is the formula?
1 by 1 plus e power minus x.
Y equal to 1 upon 1 plus e to the power minus x, and here I can write here 1 upon 1 plus e to the power minus 7.6, or I can write 1 upon 1 plus e to the power minus 7.6. What is the value of the e, if you remember?
2.713.
2.713.
Yes,
If you
sir.
are,
2.713.
yes, so just put this value and you can see. So you can just use this value 2.1771.
So 7.1.
713.
2.71 to the
7.
power, yeah, to the power in minus 7.6, and you can use right now your mobile phone or calculator to get the value and tell me what is the value you are getting.
So 0.0005.
0.0.
Sir, the total value, sir. Are you asking?
No, total value. I need the total value.
Okay,
I
sir.
need the final calculation of this value?
Yes, sir. Calculate.
Calculate and tell me. And after telling me this value, and other students are required to calculate the in value of the H2 and out value of the H2, and the in value of the H3 and out value of the H3. So calculate and tell me all the values.
So this value is coming 0.9995.
0.995,
sir.
Okay. This value is coming. Okay, just let me check what is the value you're getting.
Yes, sir. 0.9995.
Okay, so I can write this value.
Same answer.
Oh, okay, no issue. I can use 0.999 and 5.
5. Yes.
Okay. So I can write over here 0.999 and 5. Okay, so other students are required to calculate all the things, these values. Just tell me how we are getting all these values. So calculate the H2 value and H3 values, in and out values, and tell me. So I am giving all the people 10 minutes. Within 10 minutes, you can solve it.
Sir, for H2 it is 0.98.
You just calculate all the value and then tell me final value after 10 minutes.
I am calculate all the values, sir.
Sir, calculated, sir.
Okay, you have calculated all the values, so no issue. I can accept your point. Okay, so what is the H2 input value?
Sir, 3.9.
H2 into 3.9, sir.
Okay, so I can write 3.9.
Yes, sir. 3.9.
So what is out value?
Sir, out value is 0.98, sir.
0.98. Yes, sir. 0.98.
And 98 and
So 0.9804.
okay. And what is the in values of this H3?
Sir, it's 6.5.
There is 6.5.
And what is the its other values?
0.9985.
0.9999.
85, sir.
Okay, I can write over here. Okay, so everyone is getting this values, or anyone getting a different value? So let me know right now.
Still getting same value.
Sir, getting same value, sir.
Okay, anyone who is getting the different values, so let me know right now. Anyone who is getting the different values? Okay, let me know once again. Anyone who is just trying to calculate more values. So anyone who is getting different values, so let me know right now, so I can rectify the answer. Else we can move to the next part. So now it is clear to right now how to calculate the input value and how to calculate the out values.
Yes, sir.
Yes, sir.
Yeah, okay, good. So input calculation and output calculation is very easy. So this is the things we have to do, perform at each and every node. So what we are doing, as per my words, and I ask the question, we are doing the computation, the calculation we are doing. Okay, so now We are doing the thing properly. So now it's time to explain the step by step everything what we have done. See, first we calculate all the input values 7.6, 3.9 and 6.5. As you told me the answer, we are getting the same answer, no issue. Now we calculate the answer in different ways. So we have the very solution over here. So every time I got the answer. So H1 input value of the hidden layer, as a hidden layer, we have an input value that is 7.6, 3.9 and 6.5. So anyone who is not getting the thing, so use this calculation, he or she can easily understand. Now there are many activation function we have used, so but we have to stick or we have to think about the sigmoid function. Why? Because sigmoid function we have already discussed in simple way in our simple class in the logic regression, where we have determined what is the sigmoid function and what is the logical function. So as I told you while studying the theoretical term, sigmoid function will be the example of the activation function. If you do not want to use the activation function sigmoid, then you can use another function that is your ReLU function. That is we have the 10H function, the other function we can use. Softmax is one kind of the activation function. So we have many activation function you can use. But sigmoid and ReLU are the most popular activation function. I'm repeating my statement. Sigmoid and ReLUs are the most important and usable activation function. So this part we have already discussed. So this is overly and this is given here for notes purpose only for the betterment. Now this part we have already calculated. So according to the student, I got the answer. This one answer we got. Okay, there's a different answer I got it. If the little bit difference we have, so right, first 2-3 digits are same, so no issue. This is our answer we are getting. So many times I've explained with this concept the other slot, so I got the answer. So we have a different answer over here, but little bit hardy. Last fourth digit or decimal number is little bit changes only. So value after applying the activation function we got, that is the 0.994, 0.89802 and 0.9985. Why? Because some people can use a 2.7 for the e value. Some people can use the e value 0.2.71. Some people can use the e value 2.718. So due to this manner, your answer little bit change in terms of the decimal. So two or three decimal value may equal, but fourth decimal value may change. And that to this point, because what is the value we are picking as e, 2.7, 2.71 or 2.718. So that is the point you have to understand. Now, so now calculate the value for the output here. So it is given over here some bits. Okay, so I'm writing here the our answer or value, and we will see the thing properly. So what is the value we have? 3.9, 3.9 and 0.9995. Am I right?
Yes, sir.
But 0.9, this is not 3.9, this is 7.6.
Yes, sir. This
7.6.
7.6.
0,
Yes, sir.
3.8. Yes, sir, 7.6. Sorry, sir.
Okay, no issue. So this is the 7.6. And what is the value of this one? 3.9.
3.9.
3.9.
Yes,
And this is the 0.9.
995.
9.8.
What is the value?
So
98.
995.
995 we are getting
Oh, yes, sir.
995. This is the value 9802. I am getting 9802.
Yes, sir. 980.
9802. Yes, sir, 9802.
This value would be 9802. And last value we have the input value, we have the 6.5, and then we have 9985. 0. Yeah, 0.9985. So now we have some more weight values for our calculating out value. So it is time to calculate the value at the output here. So we can easily calculate. So we will receive the many or different values. So let us calculate this value. So you will calculate or calculate over here.
The calculating.
Okay, just you people can calculate and tell me what is the value you are getting. Just calculate and tell me what is the value you are getting. Just unlike the previous calculation you have done, just calculate like that one and tell me what is the value you are getting.
Sir, 1.7885.
So how we have calculated? So I'm just calculating over here. First, we are calculating the input value of output layer node. Okay, output layer node. So what is the calculation we are doing? 0.995 multiplied with the 0.4 plus 0.9802 multiplied by the 0.5 plus 0.9985 multiplied by the 0.9. Are you doing this calculation or are you doing the different calculation? Let me know right now.
Yes, sir. Doing, sir.
Okay, and do this calculation. Tell me what is the value you are getting.
Sir, 1.7885.
I can write over here first. 1.7885.
85.
Okay, and now just so this is everyone is getting this value,
Yes.
or anyone is getting the different value. So let me know right now.
Yes, sir.
Anyone
Same value.
same value. Anyone who is getting different value. So let me know right now if you are getting different value. So what we are getting, I can write over here. Say 1.7885. So this is the value we are getting. 1.7885. This would be what? This would be our. This would be
Input.
what? Input value of such node. That's a great answer I get. So what is the out value? Can you tell me right now? What is the out value? So out value we can easily calculate out value of the node at output layer. So just use activation function. So far we have used the activation function. We have the sigma. So if it is not mentioned in the question paper, so you can use the activation function. So by default you must use the activation function, that is sigma node. So we can put here 1 upon 1 plus e to the power minus 1.7885. Okay, tell me that what is value you are getting. So I can put these values over here. And keep in mind this value should be come into the 0 to 1 range only. If you are getting the more than one value, if you are getting the less than 0 value, it means you are not calculating the correctly. Just tell me right now what is the value you are getting.
0.8567.
Yes,
Zero
yes, sir.
point.
Yes, sir. 0.8567.
Okay. I can write over here on based on points. 0 point. Tell
Eight
me
five
0.
six seven.
8567.
8567. Okay, got it. So this is the value we are getting. So I can write like this value 0.8567. This is the output value. So what we have been observed? Have you observed something? Are you observing something over here? What you are observing? Can anyone tell me right now what you are observing? Just tell me right now what you are observing over here. Yes, tell me.
Sir, we
Uh,
have output as a given 0.92.
Okay, super. But here our prediction is coming 0.85. So now
Yes,
we have
sir. Yes, sir.
yes, sir. Yes,
now
sir.
Error.
we have error. So now we have an error. So now we have also done the calculation with the other slots over here. So I have this calculation. We are getting the values 0.857, so which is close to the no issue. Again, other slots. So every time I am explaining the same thing, so I will not remove the PPT. I will keep the PPT. So now this is our calculation. We got it over here and get the summation of these points. So 1.718 something we got it. So 0.85 we are getting. Okay, by using the sigmoid function, that is activation function. So what you are observing after this point, what you are observing, this is the predicted values. So predicted values we are getting over here. So we have error actually. We have error. Okay. So theoretically, what you are observing, this is a slide which we can easily understand. Theoretically, with those weights which are given into our question paper or in our exercise part in the numerical way, our neural network will calculate 0.85 as our test score. Okay, if you're looking for the test score marks, but however, our target was 0.92. That was our target. That was actual value. But our prediction we are getting the 0.85. So our result was not poor. Our result was not poor, but it just not isn't the best because we are not close to that point. Suppose we are close to the 0.90 something we are getting. So we can say we are close to the actual output, so there will be no issue. But here we have some error. So we just got a little lucky when I chose a random weight for this example only, nothing especially. But from this point, you have to really identify how we can say. So that is the point, calculating the error. I can write over here for a betterment. Uh, our result, our predicted result is not close to the actual value, actual value that is our target value. That is our target value. And this predicted values we got as our predicted result we got that is a 0.85 and while actual value was a 0.92. So we have, so I can say right over here, so we have an error in the model, in the neural network model. I can write over here, that is a point. So what is the formula by which we can calculate the error? So let us move to our important point. If you remember the regression, so in the regression, what we have used? MSE, that is mean square error.
Predicted minus.
Yeah. Okay, I got it. I can understand the predicted values minus our actual value. So that is a we can use the summation function.
Yes,
But
sir.
here, yeah, definitely we can say. So here we have a loss function. So we have to keep in mind properly, and we are squaring the our thing to get the our thing properly. So rather than using the absolute value, we are squaring. So we have used the mean square error function, that is our loss function, and by which loss function we can do. Okay, so this is the simple formula that is known as the summation of loss function, that is known as the summation of, that is identified by the summation of the 1 by 2 0.0, that is our output, that is we have planned, that is a target output, and our actual output we have, that is a y by which we are getting. So y will be the predicted output. I can write over here. Y will be the actual output. Okay, so y will be the actual output and O is our predicted output. So it is written over here, this is a predicted output, and y becomes our actual output. So by putting these values and by squaring, we are dividing by 1 by 2. So we are trying to minimize the thing properly. Now this function is known as the mean sum squared error. Okay, mean square error, this is a different thing. This is the error we are getting with the help of the mean sum squared. Why I am using the mean sum squared error? See, this is a formula which is known as the, I am writing over here, mean sum square, not mean square error. So this is the formula we have to understand. Do not mix up the thing. Mean square error formula is totally different as we have seen in the regression. But here what we have, mean sum square. So why I am putting the mean sum square? Because in our model we don't have the one information. We are designing this model. We are trying to calculate information based on the other inputs. So what are other inputs? Now it's time to calculate the 1,5 as input features, 3,6 and other part. So after applying all these calculation, we have to identify what is the sum square error we are getting. So we need to calculate the mean, and that mean will be have to divide by the, we have to use by the 2. So that's why we have this formula. So this formula we have to keep in mind. So this is the important point you have to understand. This is the formula which is known as the mean sum squared and not the mean square error. They're a little bit different, you have to understand. So the mean sum squared loss function is the sum over all the data points we have to calculate, and now the square of the difference between the predicted and actual target values, and divided by the number of the data points we have. So here we have the 2, so we can divide by the 2 as we have the this one. So 0.5 means we are assuming that we have the 2 data points we are using, else we can use the divided by n, and is the total number of the data points. So now we have the loss function. This our goal is to get the answer close to the our target values that we are looking for, or actual output as we are looking for. So that means we need to have the close to the no loss at all. So we must get the answer close to our actual output. So we can say we are not having the much losing the data. It means our network model is well trained. And every time you have to do this step again, it is a tricky process. So what is the method by which we can do? So after this calculating the error, we have to determine the one more method, that is the backpropagation method. So here we have to apply the backpropagation method to minimize the error. I'm speaking once again. We have to apply the backpropagation method here to minimize the error. And this error means we're talking about the loss. So now this formula is clear to right now?
Yes, sir.
So this is the formula we have to use. But if we don't have, very frankly speaking, I can write over here in simple way for your betterment. If we don't have, this is where this one, yeah, yes, I can add over here. So
Sir, one doubt, sir.
Yes, please tell me.
Sir, in the calculation, sir, can you go to the previous page once?
Yeah, okay.
Sir, shouldn't the error be 0.07 minus 0.07?
Yes, of course. While scaling the everything, we will get the answer correctly. No issue. We are scaling.
So I'm asking, sir, it's written 0.7, so it should be 0.07.
So just I'm doing here correctly. So no issue. I'm just, that's why I'm using the blank description. No. I'm doing correctly over here. I know I have seen that part. So I'm writing here from our example. From our example, let us determine. Let us determine the loss. Okay. So what is the loss function? As we have seen the loss function. So from this point, what is the loss function? Loss will be we don't have the much information. We don't have the much information. Much information means we don't have the many data inputs. So we have the how many data points we have? Just can you tell me now? That is the features. How many data points we have? Two features. Okay. How many data points we have?
Two data points.
So that is the question I'm asking right now. How many data points we have? How many data points? We have two. Okay. So what is our what is the formula? Divide 1 by 2. Okay. Now tell me right now, is it clear? 1 by 2 multiply actual value or actual minus predicted, or you can say predict minus actual. Doesn't mean we, after all we are doing the squaring. So 1 by 2 actual minus what is actual values? 0.92.
0.9.
And what is the predicted value? 0.85 we are getting.
0.85. Yes.
And after squaring this point, so 1 by 2, and what is the, we are getting the values over here?
0.07.
0.07. So I'm just getting over here right now. So can you tell me right now what is the value we are getting over here? Just use the calculator. Tell me what is the value.
0.00245.
0.0059.
0059.
245.
0.002.
245.
Okay.
45.
Yeah. Okay. No issue. So this is what, this is our loss we are getting. But ultimate, this loss is not a big loss we have. We say just we are close to the our answer. But we, our objective. So what is our objective? Our objective should be, our objective should be keep minimum loss. Okay, minimum loss, or minimize the loss. You can say minimize the loss, minimize the loss. And this is the done by a method, so that is known as the back propagation. That is known as the back propagation method. That is known as the back propagation method, by which we can do. That is required over here. That is known as the back propagation method, by which we can do. And such neural network, when we are applying the back propagation, that is known as the backward neural network. That is known as the backward neural network. Now, is it clear to right now? Everything I'm calculating in front of you, I'm getting everything. So that is a neural network. If I'm choosing the simple calculation, so how we can choose and how we can solve. Okay, so is it clear to all right now?
Yes, sir.
Okay, so this was a simple example by which we have seen what is the our thing we are getting over here. So after this point, let us focus on the other points what we have to do cover, that is multiple perceptrons. So I have some example as we have already discussed, but I'm taking the one more part over here. So what is a multi-layer perceptron? Some students can answer this question and some students do not have any doubts. So to remove their doubts, I have the multiple perceptron concept right now as a theoretical point. This is why multiple perceptron I'm taking, because in coming days or maybe in the coming future, we will work on the deep learning. So this should be clear. So that's why I have this point right now. So now tell me right now, the numerical portion is clear so far. We have discussed. Is it clear to all right now?
Yes, sir.
Yes, sir.
Any doubt? Any student who have any doubt in the numerical portion, please you can ask right now.
No doubt, sir.
So far
Yes.
how to calculate the loss and how to calculate the other thing is clear. Okay, that's great. So now it's time to focus on the multi-layer perceptron. So or multiple perceptron. So multi-layer perceptron is one of the most common neural network model and that used in the field of the deep learning. I'm speaking once again. I have spoken many times. So it is used in the field of the deep learning and often referred to as a vanilla neural network. So it is only the naming convention, just like the Rajkumar of Raju. So it's just other name we have the vanilla neural network. So an MLP, that is multi-layer perceptron, is simpler than the complex model of the today's era. However, the technique is introduced have paved the way for the further advanced neural network. So in this case, what we have in the multi-layer perceptron, we will not talk about the single layer. We will talk about the multiple hidden layers. So multi-layer perceptron used to use in the various places. So it is used for the variety of the tasks such as the stock analysis. Because we will not talk about the single stock. We will analyze the many stocks simultaneously. Parallelly computations will go on internally. So this deep learning approach or deep learning based application we have. So computation we need fastly. So that's why the hardware technology and software technology are growing change rapidly. And now image identification, spam detection, and election voting prediction. So these are the various example where we can use the multiple perceptron application. So this was the important point we have to understand. Now, have you seen the basic structure of the our perceptron, or we can say the have you seen the architecture of the neural network? So this is a simple example. So a multi-layer perceptron consists of the interconnected neurons transforming information to each other, much like the human brain. And each neuron is assigned a value, and the neural network can be divided into the three important layers, of course, as we have discussed many times: input layer, hidden layer, and output layer. So what we have, the if talking about the multi-layer perceptron or multi-layer neural network, so we have the one output layer and one input layer, but we can have the many hidden layer, and each and every hidden layer may have the one node, more than one node. So here we have a three node or four node respectively. So this is a simple example, and this is a simple diagram which describe the multi-layer perceptron. Now, yeah, this is example I'm taking here. Okay, that provides a big confusion. So to avoid the confusion, I have taken this simple example. You can see this I1, I2, I3 are the input. Just tell me right now, so I can write over here properly. Just
Yes, sir.
yeah. Can we say I1, I2, I3 are the input of for the input here?
Yes,
So
sir.
this is our input. This is our input here. And these two are what we have. These two are known as the hidden layer. Hidden layers. Okay, and this is our output layer. Yeah, super. You are getting properly, so I'm happy to hear. Now, and this is the hidden layer, and here we have the input layer. Can we say this is the feed forward neural network? So I will ask step by step. Can we say this is the feed forward neural network? Feed forward neural network. Can we say this is a feed forward neural network?
Yes, sir. We can.
Why? Because it's very
Yes,
simple.
sir.
It is very simple because we are moving from input to output layer. So that's why it is a feed forward neural network. Yes, of course, we can say.
Yes, sir.
Second, yeah. So this is a right answer. We can say. Can we say this is the single layer feed forward neural network?
No,
Can we say
sir.
this? No. Why? As we
Yes,
know,
sir.
yeah,
No, sir.
yeah,
It
yeah,
it has two
because
hidden
Because
layers.
it has the more than one hidden layer, definitely. So it can we
yes, sir.
say, yeah, can we say this is example of the multi-layer feed forward neural network?
Yes, sir.
Yes,
Yeah,
sir.
Yes, sir.
yeah, that is a simple point. You are getting properly. So now third, fourth point, which is more interesting. Can we say this is a fully connected or a fully connected neural network which is following by the multi-layer? So
No,
I can
sir.
speak multi-layer fully connected neural network. Can I say this is
No,
No,
sir.
sir.
No,
why?
sir.
Why?
Sir, in the
Because
hidden
Sir,
layer we can
because
see.
Yes, sir.
Suppose
They
that
are not connected.
H2 is not connected to H6, sir. That's why.
Because some of the nodes are not connected to the all nodes of the other layer or other
Yes,
we
sir.
can say the other steps, we can say other next layer, we can say. So that's why we can say this is not example of the fully connected neural network, but this is a simple example of the our multi-layer feed forward neural network. And that is a good point you are getting properly over here. So that is a great point. Yeah, I'm happy. So the concept should be clear. So if you don't have any doubt, so then it's okay. But if you have any doubt, so you can ask me any more questions over here, so we can discuss properly.
No
Tell me
doubt.
right now. No doubts. Okay, great answer. Anyone who have any doubt?